Hello and welcome to another WJEC A level physics question. This was question 4 on the June 2014 Unit 4 paper on simple harmonic motion, which is now in Unit 3. And what we've got is a mass on a spring oscillating with SHM of frequency 3.47 Hz. We've got to calculate the spring constant of the spring. So as soon as we see a spring question, we know that we can use T equals 2 pi root m over k. So let's write that down. Let's square both sides, just doing lots of work in here so that people can see where the rearrangement comes from. And then finally we can replace or exchange the positions of the k and the t. The period is 1 over the frequency. The frequency is 3.47 Hz, so we could work out the period and substitute into the equation. Or if we want to do everything in one go, we can replace, sorry, that's t squared over there, we can replace the t squared by 1 over f squared, in other words an f squared on the top. So I'll put in the figures, 4 pi squared times 0.32 and multiply by the frequency squared of 3.47 Hz. So let's put that into the calculator. And we end up with about 152. Now we mustn't forget the unit. The spring constant unit of newtons per meter is a very common one for exam questions for the unit mark, so never forget that one. Next we've got to show that the angular velocity omega of the oscillations is 21.8 radians per second. So here the simplest way of doing this is to use omega as 2 pi f. So 2 pi times the 3.47, which gives us 21.8 naught. Just giving an extra figure just to prove I've actually worked it out. Next we need to find the maximum kinetic energy of the mass. Well, the formula for kinetic energy is half mv squared. So it's half times 0.32 times the maximum speed squared. Now the maximum speed for SHM is given by V max is omega A. So here we can multiply the half m by omega A all squared. So we've got omega was 21.8 and the amplitude 8.5 centimeters. Mustn't forget to turn the centimeters into meters. That's also squared. So putting that into the calculator gives us 0.55 joules. Could of course work out Vmax separately and substitute in. Okay, the question continues by asking us to find the maximum resultant force acting on the mass. Well, resultant force is mass times acceleration, so maximum resultant force is mass times maximum acceleration. And for SHM, the maximum acceleration is given by plus or minus omega squared A, and we're only considering the size of the force, so we don't need to worry about the minus option. So 0.32, okay, pen, why have you decided to stop writing? There we go, 0.32 times 21.8 for omega squared times 8.5 centimeters for the amplitude. If you put those into your calculator, you'll get an answer of about 12.9 newtons. For the next part of the question, we're given the displacement against time formula for this SHM as x equals a sine omega t plus epsilon. Nowadays the spec has changed from sine to cos, but the process of solving this is exactly the same. So let's do a little bit of algebra just to show how this would work. So first step, divide both sides by a, which gives you sine of omega t plus epsilon. Sine minus 1 of both sides will leave you with omega t plus epsilon. Epsilon then is sine minus 1 of x over a minus omega t. Let's put in the values. Sine minus 1 of minus 1.4 over 8.5. Now note, because they're both in centimetres, there's no need to convert them into metres. And then take away 21.8 for omega times t. Now make sure your calculator is in radians mode, otherwise you won't get the correct answer here. And putting those values into the calculator, we end up with minus 2.35 with a unit of radians. Thank you very much for listening. Please remember to like and subscribe, and feel free to add any comments below the video. Goodbye.